Pressure, is important for breathing. It also has a big effect on our weather. Variation in the atmosphere pressure are what cause the changes in the weather. And so by monitoring changes in pressure, that can help us to predict the weather. That, of course, is still not an exact science, right? The weather is difficult to predict. A high pressure front is usually associated with clear weather, with good weather, and low pressure is usually associated with unstable weather. So here we have a sample map of the United States showing there's a low pressure front here and a high pressure front here. And so there they would predict that there's going to be some unstable weather. Of course, they use other factors to help predict what's going to happen. As you go higher up in the atmosphere, the number of gas particles in a given volume, the concentration, if you will, decreases, and so there is less pressure from the atmosphere at higher altitudes. Here we have what looks like two mason jars, and they both have gases in them. This gas, we see there are fewer particles in this same volume, and here there are more particles in the same volume. These particles are moving and they're going to collide with the walls. So I think it makes common sense that these particles are going to run into the walls more often. There will be a higher pressure here because of more particles of gas. Yeah. Come on. So pressure also has to do with your ears popping when you change altitude. This can happen when you fly, or if you just go up to visit Grant Grove. Your ears will pop on the way up and they'll pop on the way down. And here's the reason. So here's a picture of your ear. You have an eardrum in here that separates your outer ear from your inner ear. And that's really nice because then when you go swimming or you take a shower, you don't have water getting inside your ear. It just stays out here. Well, inside your ear there is some air, and that is connected to the inside of your throat through the eustachian tube. What happens as you go up in altitude, the reduced atmospheric pressure causes the pressure on the outside of your eardrum to be less than the pressure on the inside. This is still normal pressure where you came from. And so that causes your eardrum to bulge outward, and that can be uncomfortable. If you have an ear infection, that can be excruciating. So it causes a bulge outward. So if the pressure difference gets large enough, then your eustachian tube will open a little bit and let that extra air out. And we experience that as a popping sensation. When you're coming back down the hill and the outside pressure is increasing and the inside pressure is lower, then your eardrum bulges the other way. In my experience, it's harder to get my ears to pop coming down. It's harder to get the air to come in than it was to come out. And so sometimes, I can't hear very well for hours later. It's annoying. Any questions? How do we measure pressure? A very early way to measure pressure, which still is very useful today, is a barometer. Barometers are used to measure atmospheric pressure. And this is an illustration of a very simple barometer, probably typical to the first one that was used by a scientist named Torricelli. So there's a dish of mercury here and a glass tube. And so this glass tube was originally filled with mercury and then tipped over very carefully so that it didn't spill. And you can sort of get the same effect if you take a sink full of water and a cup, and you have the cup completely submerged underwater, and you put the cup upside down, and then you bring the cup up out of the water, but you leave the lip of the cup under the water. If you do that with a clear cup, you'll see that the water stays in the cup. None of it comes out. With mercury, if the cup or the tube is long enough, we'll see that some of the mercury comes out, and what's left up here is a vacuum. There's really nothing in that. It's not air, it's a vacuum. What Torricelli observed is that if you take this thing and you walk up a mountain with it, sounds a little difficult, you walk up a mountain with it, then the height of the mercury column goes down. And as you come back down the hill, it goes back up. What the heck? You know? You think about these early scientists, they must have been just very, very creative. Why is the mercury staying in there at all? Why does the water stay in your cup? Why doesn't it run out? Most little kids in the bathtub do that with cups and things, and it's fascinating, right? It's just really fascinating. You can do it on your head, come up and it stays in the, and you pull it off and it runs all over your face. Very fun. Can't do that with mercury though. Why does the mercury stay up there? Gravity's pulling it down, but atmospheric pressure is pushing down on the surface of the mercury, pushing down on the surface and supporting this column of mercury. In order for this mercury to run out, this level has to go up, and the atmospheric pressure is resisting that. So we get a balance between gravity pulling down and the atmospheric pressure pushing up. And it turns out that at sea level, the atmosphere will support a column of mercury that's 760 millimeters tall. And we did not choose that number. That is just how it is. At sea level, the column of mercury would be 760 millimeters. And that is simply measured with a ruler. So it's a length of a column of mercury, which is kind of a weird unit. It's called a millimeter of mercury. You can convert millimeters into inches, and you'll find out that that's equal to 29.92 inches. So that would be 29 inches. If the pressure is higher, then the height of the column of mercury will be higher. If the pressure is lower, the column of mercury will be shorter. Okay? We used to have mercury barometers mounted in the classroom. And people are very paranoid about mercury, and so they made us take them down. If you really, really want to see one, though, I know where one is, and I can show it to you. Very, very cool things. So a millimeter of mercury is a unit of pressure. It is also called 1 torr in honor of Torricelli, the guy who figured all of this out. So a torr and a millimeter of mercury are different names for the exact same thing. I think, a torr would be a really nice shorter unit to use, but we still hang on to millimeters of mercury, so now we're stuck with both of them. Other pressure units. Did not mean to do that, sorry. A Pascal, that is the SI unit. It's a Newton per meter squared. Not going to use that very much. Pounds per square inch. Here we've got that force per unit area, a pound per square inch. That's abbreviated PSI, and that's used like when you inflate your bike tires, your car tires, a certain number of PSI. There's the torr. Inches of mercury is what the meteorologists use, and then atmospheres. So 1 atmosphere is atmospheric pressure at sea level. It's 1 atmosphere. The way this chart is set up, all of these things are equal to each other. So 1 atmosphere equals 29.92 inches of mercury, which equals 760 torr, and that relationship is exact. It's defined as 760. 14.7 psi, 101,325 pascals. When you're doing pressure conversions, and you will have to do those, you can always do them in one step. I see people go through all kinds of contortions. It's not necessary. We'll be doing a lab where we're going to read the atmospheric pressure off of this little weather station we have here. This reads in inches. So today it's 29.91 inches of mercury. So pretty close to 29.92, but not exactly. You'll have to convert inches to torr or atmospheres. Just use the 29.92. You don't have to do the millimeters to inches to centimeters thing, okay? 29.92. Students often want to know, what do I need to memorize? You need this one and this one. So 1 atmosphere equals 760 torr, which is 760 millimeters of mercury. We use that one so often that you should just memorize that. Those other numbers, if you needed them on an exam, I would give them to you. Your local weather report announces the barometric pressure is 30.44 inches mercury. Convert this pressure to PSI. This is how I would probably give you conversions on an exam. I would definitely give you this row on the bottom. May or may not give you the one on the top. So we can do this in one step. Dimensional analysis again. 30.44 inches of mercury. That's not in mercury, that's inches of mercury. And I'm asked to find PSI. So I have one conversion factor. I'm going to put PSI on top. I'm going to put the given unit on the bottom. Inches of mercury cancel out. These things are all set up to be equal to each other. They are all equal to 1 atmosphere. So 14.7 PSI is equal to 29.92 inches of mercury. So I can use that as my conversion factor. So 14.7 PSI, 29.92 inches of mercury. 30.44 times 14.7 divided by 29.92. And calculator's giving me a big old mess. This 14.7 is not an exact number. I don't know why Tro put only 3 sig figs in there. I'm sure there was some sort of a reason. But that's going to limit our answer to 3 significant figures. And so this would round to 15.0 PSI. Any questions? You can find all kinds of other relationships between these pressure units, but these guys right here is all you need. Another instrument that can be used to measure pressure is a manometer. The barometer measures barometric pressure, the atmosphere. Manometer is used to measure a pressure inside of a container. And of course, we do have more sophisticated devices for measuring pressures, but these are great because they're so simple that we can easily see how they work. So here we have a container containing a high pressure gas. If we want to know what the pressure is in there, we can connect that to the atmosphere with a U-shaped tube containing mercury. If both of these ends were open to the atmosphere, if the pressure was equal at both ends of the tube, then the mercury would flow to the bottom and the columns would be equal on each side, right? This side, the mercury is lower because this high pressure gas is essentially blowing it down. It's like if you took a straw and blew, you'd push this side down, right? And that causes this side to go up. So we have atmospheric pressure out here, which we would measure, and then we can tell what the difference in pressure is between outside and inside. The difference in pressure is the height of this column of mercury. So you would measure it with a ruler, and that would give you millimeters of mercury, and then you could convert that to any unit that you want. Because this side connected to the container is lower, this side is higher in pressure. If this was lower in pressure, the column on this side would be higher and on that side would be lower. The higher pressure is pushing its side down.